We'll get like this. Then this will be so this is the displacement. Let it be x. I rotate the rod through a small angle theta. How is angular displacement given in this direction? How the torque will act? Torque will be in this direction. Okay, fine now. So what is the spring force? The spring force will be both the springs got compressed. So how the spring force? Spring force will act in this direction. So there's a point 2 about which it is hinged. Now a torque is set up here. So what is x? How to calculate? So this will be L by 2. So sine theta equal to x by L by 2, x equal to L by 2 sine theta. Now what is the resultant torque about point 2? This should be equal to minus I naught into alpha. Why negative sign? Because that torque is acting opposite to angular displacement. You look at the theta in this direction, whereas the resultant torque or restoring torque will be clockwise. The angular displacement was anti-clockwise. So therefore, negative sign let me bring. So what is the torque? So torque by the spring forces only. So this should be equal to 2 into kx L by 2 cos theta. Should be equal to ml square by 2l into alpha. Look at this condition. What can be this distance? L by 2 cos theta. So let me replace the value 2 k x equal to L by 2 sine theta L by 2 cos theta minus ml square by 2l into alpha. Okay, therefore alpha is equal to 6k by ml will be there. L will also not there. 6k by m negative sign cos theta sine theta. Theta very small. Cos theta will become 1 and sine theta will be theta. So therefore this will become alpha equal to minus 6k m 1. This is theta. This is angular SHM. What we had is a linear SHM spring block, here angular SHM. So the rod is going to oscillate. So what is the state of rod? Rod will be, I think I can show this. Not possible. Huh? Actually, both the ends will be oscillating. So this is the angular SHM, not linear SHM. So for linear SHM, the equation will be A is equal to minus omega square x. For angular SHM, it will be angular acceleration will be proportional to negative of angular displacement. Able to get this one? So this will become linear SHM. This will be angular SHM. So now what is omega? Omega will be 6k by m. So time period will be 2 pi m by 6k. So this is the expression for time period of oscillations. Okay, no, so we will, the first problem I introduced. Sir, why weight? How the weight will act? Rod lies on smooth horizontal surface. How the weight will act? Weight will act into the plane of paper. So mg will act into the mg will act into the plane of paper. Okay, fine. These are some, just make observation, it'll be very good. But I think every problem, you can't just only see the diagram and okay, I'll do one thing. So what you should do, you should disturb the diagram from equilibrium position. Earlier it was here. Now I'll rotate the rod and release. Then once you rotate, what are the forces that are acting? Yes, from there you get into the problem. What is the condition? In fact, the spring remains straight. So there's a rod like smooth or gentle surface. And what is the other condition? Springs remain straight. But what actually practically will happen, as you rotate, this point will not be here, no? So as you rotate, this point will come here. Are you getting the thing? That's why the theta I made very small. Please do make some observation. Theta very small. So if in fact practically what happened, the point, this end of the rod will not be here, will be here, no? Since theta very small, so the springs will remain the straight. Getting the idea? This one? Okay, now we'll take one more. With weight also, let it come into picture.